Unit 4, Lecture 8, Expansion Bellow and Expansion Provision. Subject Process Equipment Design. One of the method of reducing the thermal stresses in fixed tube heat exchanger is to introduce the flexible element in the shell of heat exchanger. The flexible element is called the expansion bellow or diaphragm as shown in figure. The expansion bellow consists of two shaped discs, each welded to the shell. The discs are welded together to form the diaphragm as shown in figure, and it is attached to the shell. The expansion bellow or diaphragm is used to reduce the stresses produced due to temperature difference in the tube and shell. The arrangement of attaching the expansion bellow to the tube sheet is as shown in figure. Now, expansion provision. In heat exchanger, it is necessary to make provision to allow to take thermal differential expansion of the tube and shell due to rise in temperature. In fixed tube heat exchanger, shell and tubes are fixed together. These two components will not be free to expand due to lack of provision for free expansion. Thus, considerable stresses are produced in the shell or tubes, and there is always possibility to damage the tube joint at the tube sheet. If the free expansion due to rise in temperature is prevented, the stresses in the shell and tube can be calculated as follows. Elongation of tube due to rise in temperature, delta LT is equal to alpha T LT TT. Similarly, elongation of shell due to rise in temperature, delta LS is equal to alpha S LS TS, where alpha is the coefficient of linear expansion, L is the length of the tube or shell, and T is the rise in temperature above atmospheric temperature. If the temperature of tube is greater than the temperature of shell, then tube will elongate more than the shell. Assuming the same material of construction for tube and shell, assume delta L is the mean elongation, then delta LS is less than delta L is less than delta LT. Therefore, the forces on the shell will be tensile, and it is given by P is equal to delta L minus delta LS divided by LS into AS ES. Similarly, the forces on the tube will be compressive, and it is given by P is equal to delta L minus delta LT upon LT into AT ET. And the stresses in the shell can be calculated as P upon AS, and stresses in the tube can be calculated as P upon AT, where A is the cross-sectional area of tube and E is the modulus of elasticity. Thank you.